Welcome back to our energy unit. We are in lesson 4, which is all about magnetism. If you're just now joining us, we are going through different forms of energies. And in the last lesson, lesson 3, we talked about electricity. And then today we're jumping into magnetism, which is pretty simple. We're just going to go over the basics. And then we'll go on to the next form of energy. So in your notes, you have a list of items. I want you to just hypothesize which of these items you think will be attracted to a magnet. Just check yes or no. Yes, it will attract to a magnet, or no, it will not. And then I want you to check your answers with mine. All right, so we see paper clip, scissors, nuts and bolts, screw. All of those have magnetic properties. They will attract to a magnet. And what I want you to look at now is, what do these 4 things have in common that make them magnetic? Now, perhaps you said, well, they're all a metal, and that would be correct, but being a metal does not necessarily mean that it is magnetized or attracted to a magnet. Specifically, there are 3 metals that are magnetic materials, and you need to make sure that you add this to your notes. So iron, cobalt, and nickel are all magnetic materials. You can have objects that are a combination or an alloy of these materials, and they would also be magnetic. So magnetism is a force very similar to gravity, but it's also a form of energy. And by definition, it's the force of attraction or repulsion of a magnetic material due to the way the electrons are arranged. So objects that are magnetized have a very strict arrangement of electrons. Now, magnetism is not a new discovery. It was discovered many, many years ago by the Greeks. They actually found a mineral, or discovered a mineral, that we call magnetite today. And they noticed that this magnetite attracted some metals to it. Now we know that those metals had to have iron, cobalt, or nickel in them, or an alloy of those materials, to be attracted to the magnetite. But this was a discovery that is ages old. So we're just going to go through some different facts about magnets. And as we go through, feel free, if I'm moving too fast, to just kind of pause the video, because you're going to want to make sure that you get all of this information in your notes. So the ends of a magnet are where the magnetic field is the strongest. You can see in my picture here, these ends of the magnets, we call them poles. And every magnet has a north and a south pole. And the law of attraction that we learned about in our electricity lesson is going to also apply in our magnetism lesson. So the law of attraction, remember, says that like poles repel one another and opposite poles attract. So the same is true with a magnet. If I have 2 bar magnets and I get the north pole of one close to the south pole of another, they're going to attract to one another. And if I get 2 similar poles next to each other, like the north end of a magnet against the north end of another magnet, they're going to want to push or repel one another. And we can actually see this if you were to take 2 bar magnets and put them side by side and put an index card over the bar magnet and sprinkle it with iron filings. You would see something similar to what you're looking at in the picture. You would actually see the magnetic field attract when you have bar magnets of opposite poles next to one another versus bar magnets with similar poles next to one another. You can actually see the magnetic field pushing the 2 bar magnets apart. So the law of attraction applies with magnetism just as it does with electricity. Another thing you need to make sure that you know is the poles of a magnet always come in pairs. So every magnet has a north and a south pole, which means if you were to cut that magnet in half, you get 2 new poles. So you can see bar magnet, I have a north pole and a south pole. If I chop that in half, I get 2 new magnets with 2 new poles. You also have a region, like an invisible region around a bar magnet that we call the magnetic field. And if you'll look at this picture, one of the things I want you to notice is the field is stronger at the poles of a magnet. So that's something that you need to make sure that you know. You can see it's a lot more dense towards the north and the south pole, indicating that we have a stronger source of magnetism there. You also need to know that the Earth is one giant magnet, which is how a compass works. So the north end of a compass is drawn towards the alignment of the Earth's magnetic field. The Earth is magnetic because its liquid outer core is composed of iron, and we know that iron is a magnetic material. So when you have a compass which works off of the magnetic principle, it will align with the north and the south pole of the earth, and it can help us tell direction. So another thing we need to know about magnets is there's two types. So we can have permamagnets or permanent magnets, which are what they sound like. They are permanent. They keep their magnetism all of the time. And a good example of this would be just a simple bar magnet or a refrigerator magnet. Electromagnets are temporary. They have to be created by running electricity through the magnet. And this creates a magnetized piece of equipment that's used in a lot of different areas of real life. So the alternator in your car runs off of electromagnets, speakers, motors, all kinds of stuff. So you can see in this picture that we have like a voltage source. You got to have a power source. You've got to have a conductive material. A copper wire would be a good example. And then you have to have something that's made of magnetic material, such as an iron nail or an iron rod. And you can see in this picture, you just wrap the conductive coil around the iron or the magnetic material and have a power source, and that creates an electrical current that flows through, which generates a magnet. So one of the famous labs that's done in high school and middle school classrooms is you can create your own electromagnet and actually pick up magnetic materials like gem clips. Which is kind of neat. But I want you to know that electromagnets can be made stronger by increasing the number of coils. So if you'll look at these four pictures, they're all representative of electromagnets, but A looks different than B, which looks different than C, which looks different than D. And so if I were to ask you which of these electromagnets are the strongest, I would hope you would say D. And I want you to know this because the tighter the coils and the more coils you have wrapped around your magnetic material, the more magnetized our electromagnet's going to be. All right, so other ways that we can make electromagnets stronger, besides increasing the number of coils, is increasing the thickness of the conductive material. So if I get a thicker copper wire, I'll have more magnetism. Also increasing the length or the size of the conductive material, or not the conductive material, but the magnetic material, like the nail or an iron rod. Would also increase the strength of the electromagnet, and then increasing the battery size, of course. If I get a 9-volt battery versus a 2-volt battery or a 3-volt battery, it's of course going to generate more electricity, which is then going to create a stronger magnet. All right, that concludes our magnetism lesson, and I will see you again for lesson 5.